bacteria can survive in a salt solution, we call them halophiles. This is what we talk about in the microbiology class. Let's say Staphylococcus aureus. That is the reason on the skin surface you will see a Staphylococcus aureus. Although you're sweating a lot in the summertime, you still can get the isolates because they like the salt environments. So that's called halophiles. They could inhibit the gram-negative bacteria. Second, because of the gram-negative bacteria is dead, they actually promote a beneficial bacteria to grow, which is lactic acid bacteria. Now, what are they? Leuconastic and lactobacillus and the pediococcus. And the pediococcus for itself, it will actually generate the pediococcin. That is an antimicrobial, could kill the bacteria. So the idea is we need to let the lactic acid bacteria growing, then could going through the promotion process, could going through the fermentation process. Now it is not a microbiology class. We don't want to dig in here too much. From the food chemistry standpoint, what we really care is another function of the salt. Because fermentation, we need a sugar. So we needed to extract the sugar. That's why we need to add salt. Because salt, they could help to extract sugar from the juice of letters, which means glucose, maltose, all kinds of the sugar, monosaccharides will come out. That is a resource to going through the fermentation process. Now, obviously, when you add water there, and also you cover it, the oxygen is almost gone, or very limited, less than 1%. Okay? Another thing we also want to mention, this salt concentration is also very tricky. You have to do 2.25 to 2.5 because the salt concentration is highly related to the firmness of the letters, which means the texture will be affected. So what are how it is affected? The research has been done. Have the curve comes out. So we had this is soft at the bottom. This is firmness for the y-axis, and the x-axis will be the concentration of salt. And the curve is very interesting. It is like a normal distribution. It's like this. Does not mean the higher concentration of the salt is good. So what happened is, people started to using the concentration is only 0.7%. They find it's very soft. Then people thinking about, I'm going to add more. If they are adding more than 3%, typically 3.4%, they find the same thing still very soft. And then the people think about, we're going to be using something in the middle. How about if we use about 2.5%? That will be the firmness. So that's why we want to make sure it is firm. So certainly we don't want the sauerkraut is like a very soft one. So we using the range is about 2.25 to 2.5%. And there is a range for that. 0.7%, it is actually soft. 0.8 to 1.5%. This is a medium to firm. Then they jump down to 2.2 to 2.5%. It is very firm. And then 2.8 to 3.4%. They started from medium and go back to soft. So that's very interesting. The concentration of the salt, it is affecting the firmness and also the texture of the shredded lettuce during the fermentation. Okay, so this is a very interesting stuff we want to talk. Now we want to talk another product, which is pickles. So everybody knows about the pickles. We don't need to introduce you too much. We did that before in the lab also. So pickles, instead of we using shredded lettuce, what we got to do? We add a cucumber. Okay, we add some cucumber there, which is all obviously shredded cucumber. We cut them into two. That's a shredded cucumber. Now, of course, different types of the cucumber will have a different products. Then we also going to add a salt solution. And this salt solution needs to be very high, not 2.5%. Typically 5 to 20%. And the commercial industry, what they do, they are using is 15 liter of 15 gram of salt. If I remember, the 15 gram of the salt into 1 pound of salt. 1 pound of salt into 15 gallon of the water. And you could do the calculation. 450 divided by 15 multiplied by 3.670. You could do that one by yourself. And that was the gallon, so you go here, that's a formula, and then you do this divided by that, that's 30. So roughly you would see about like 8.7%. So that's what's the industry what they do, is 1 pound of salt into 50 gallons of the water, about like 9%. Okay, so they're doing through the fermentation. Now the function of the salt are all the same. It's going to be to inhibit the gram-negative bacterial growth. Cucumber surface, there's a lot of the enterobacter. We want to promote lactic acid bacterial growth, and the cucumber surface naturally has some lactic acid bacteria. Typically like Leuconostoc, Lactobacillus, Pediococcus a little bit, they promote them to grow. So the whole process is about 20 degrees Celsius, about like 3 to 4 weeks. What I want to say here is, did you notice that there is two things happens for the pickles? Number one is the color change. So when you add a fresh cucumber, it is yellow. Oh, sorry, it is green. But when you see the pickles, it is usually yellowish brown. So what happened? This is something we could explain to you a little bit. What is the pickles originally? The color, the green color. So why the green color? Because the component is chlorophyll. What it looks like, the structure, you have a nitrogen. In the middle is magnesium. Then you have a nitrogen. You have a nitrogen here. You have a nitrogen here. If you want to draw it somehow like this, somehow like that, and this go down like this. This is go down like this, and they connect it here. They connect it here. They connect it here. They connect it here. Okay, it's a chlorophyll. Then the chlorophyll, when you are exposed to the salt solution going through the fermentation process, obviously you have acid generated. Because the final acid is about 3.1 to 3.4, that's a pH value. So the acid generates what gonna comes? What gonna results? Magnesium gonna gone. And also there will be extracted 515 will comes out. Alright, so what's the final products? The final products called 50. And this 15 is yellowish brown. So that's why you see the pickles, which is at the commercial store, it is all looks like yellowish brown color, and that is the reason. Because after fermentation, this acid reacted with the chlorophyll, extracted the magnesium and 515, which is one component of the polyphonic compounds, and it become the 50. Then that turns you yellow brownish color. That is a question I always ask in my microbiology lab. I'm not doing an exam, I just ask them, but barely have a student knows why its color looks like the yellowish brown color, okay? Another thing I also want to mention from the safety standpoints, because in the first class we mentioned about the water and the water activity. Now, sauerkraut and the pickles, both of them, we all call them canned food. You should always remember. Canned foods, we call it's a low acid food, which means the pH less than 4.6, water activity around 0.86. This is a big risk for spawn-generated bacteria like Clostridium, especially Clostridium botulinum. So in the West Virginia area, we used to be working with Department of Agriculture to set up the rule for that. And Dr. Kenny worked for this area a very long time, and he had an assistant, which is Susie Clyde, and they worked together. They set up a rule at West Virginia is the pH less than 4.0. That means the fermented is completed. So that's the only regulation here set up by the Department of Agriculture. If we call it is a safe critical limits because that is much less than that. So 4.6. Okay? So this is something we mentioned about. Ideally, we have a last products. I haven't talked, but we don't have enough space. We just want to mention briefly here. So sometimes we have another product which is called olive. This is you could get from the eating park for the breakfast. It could be green, it could be like black. And the people don't like it. Lots of people, I don't like it too because it tastes very bitter. So what happened for the bitter taste? Because outside, on the surface, there is a polyphenoic compounds, which is called, the spell name is called alulapine. This polyphenolic compounds makes olive very bitter. So we don't like it. Now, so what they do? Before they do any type of the fermentation, the same thing using a salt. The concentration a little bit different. The concentration they're using 7 to 10% of the salt. Then the other process very similar from the chemical standpoints. But what they do at the beginning? They will be immerse the raw olive into 2 to 4% of sodium hydroxide solution. This process we call it's lying process, L-Y-E, called a lye. The idea of this is to remove the polyphenolic compounds, so make it less bitter. But you cannot completely remove it, so actually it is still relatively bitter. Now, difference between the green and the black. For the green one, we don't want to be too bitter, so we do a secondary lying process after the first one. So after fermented, we're going to be dipping into the sodium hydroxide solution. But the tricky thing is that because after fermentation there is a lot of acid going to generate, and then if you immediately are going to be dipping into the lye solution, the sodium hydroxide will be neutralized with the acid. It doesn't have anything to do. So you have to rinse to clean it first, then you do the second lying process to further remove the bitter taste. So that's the only difference. Okay, I have a slides for that. I could be uploaded it onto the eCampus, and you can read about that afterwards. Okay, so this is what we have. Talk about these 3-4 fermented products. And this Thursday we will talk about the oligosaccharides and the starch, and also the table sugars manufacturing. Okay.